We have the last section that we're going to cover in Chapter 3, Section 3.5, which really deals with transformations. And I did allude to that just a little bit, but we're going to go into more detail and how do you know whether we move up, down, left, or right. And as we work through these things, the same rule applies as long as you know the original family, the beginning graph, then you can do almost anything with it. Now, in this particular problem, transformations, basically what you need to be concerned with are the following. If it's directly connected with x, which may mean it's inside a set of parentheses with the x variable, or it might be under the square root, or it might be in the fraction, in the denominator along with the x, but it's directly connected to x somehow. If that is the case, then that means we will be moving either left or right. The problem is that x doesn't necessarily behave. So if it says x plus 2, most of us would think, oh, I'm going to move it 2 to the right because of that plus 2. X's don't behave. And yes, we will move it 2, but instead of moving it 2 to the right, we will move it 2 to the left. And so realize those are some things that we need to consider. Now, if it's not directly connected to x, in other words, it's outside of the square root sign, or it's outside of the absolute value sign, it's outside of any set of parentheses that have to do with x, then that's an up or down. And the really nice thing about that is that actually behaves. If it says plus 3, that means we're going to move up 3. If it says minus 2, we're going to move down 2. But what we have to do is we have to remember that we are looking for the original points, and that's why I gave you all those original points in the last section. That's where we're going to start, and we're going to do things with them. We might move them left, move them right, move them up, down, and we can even stretch or reflect, and those are the things that we're going to be looking at over these next 13 examples. So we begin with example number 1. This first group, we are asked to write an equation that results in the indicated translation. So we have the absolute value function. So that means y equals the absolute value of x. But it's shifted 9 units upward. Towards the up, that means it cannot be directly connected to x. So that means it's the absolute value of x, and then we want it to go 9 up. Well, it actually behaves, and so it is plus 9. And so there would be the answer for number 1. Number 2 asks us to do the square root function, shifted 9 units downward. Well, since it's an up or down, it's not directly connected to x, and so we would get y equals, it's the square root function, so the square root of x, and we're going to move it 9 units downward, which means it's minus 9. You cannot have this radical going over, because then that minus 9 would be directly connected to the x, and that would mean something entirely different. Not 9 units down. If the radical would go over here, that would actually mean 9 units to the right as to how those points would shift. So where we're actually going to get to see the shift is in this next group, 3 through 6. And so we are told to start with the graph of the basic function and then use techniques of shifting, compressing, stretching, and or reflecting. Now we're going to begin just by shifting. Then we'll look at compressions and or stretching. In essence, they're the same thing. And then finally we're going to look at how do we reflect and when will that actually show up. So we start out with f of x equals the quantity x minus 7 quantity squared plus 4. Now the first thing we have to do is determine what family is this. Well, we have x and it's being squared. So this is the square function. Now we go back to last group, and the square function has 0, 0, 1, 1, negative 1, 1, negative 2, 4, and 2, 4. Those are 5 points, and That's where we're going to start. But this tells us to do some things. For example, this minus 7 is directly connected to the x, so that means it's either left or right. More importantly, since it does actually connect to the x, it does not behave. So this is telling us normally minus 7 would say go 7 to the left, but really we're going to go 7 to the right. But then this plus 4. This plus 4 is not directly connected to the x because it's not within parentheses or a fraction or a radical sign, and so this is going to either go up or down. As it turns out, it does behave. This plus 4 means exactly what we know it to mean. That means 4 up. So what we're going to do is we're going to take our 5 points, and each one of those we're going to go 7 to the right and 4 up. So from here we're going to go 7 right and 4 up. So this point right here would be the point 7, 4. We take this point, go 7 to the right and 4 up. This becomes 8, 5. Take this one, go 7 to the right and 4 up. That is 6, 5. This one, go 7 to the right and 4 up. Becomes 9, 8. And then finally this one, go 7 over and 4 up. And this would be the point 5, 8. And this is where our new parabola goes. Our new square function. It's going to have the exact same shape. It's just been shifted 7 to the right and 4 up. And that's exactly what this is telling us to do. As long as we know what the original family looks like, that's all we have to do is shift 7 to the right and 4 up. Example number 4. We have f of x equals square root of x minus 3. So I think back, my square root has the points 0, 0, 1, 1, and 4, 2. Those are the 3 points that I begin with. Now look, the only thing I have going on is this minus 3. I ask myself, is it directly connected to the x or is it not? Well, it's not directly connected to the x because this is not over it. So as a result, this is either an up or a down. It's not a left or a right. More importantly, since it's not directly connected to the x, it does behave. It does exactly what we think it should do, which would be it goes 3 down. And so that's what we're going to do. We're going to take this point and go 3 down. So this becomes the point 0, negative 3. This point moved 3 down will become the point 1, negative 2. And this one moving 3 down will become the point 4, negative 1. And this is where our new graph is going to look. It's the same shape, the same square root, because that's the first thing we determined. It's square root, but it's going to look 3 down is all it's going to do. Example number 5. F of x equals the absolute value of x minus 2. Well, it's rather obvious this is the absolute value function, so it's going to have that V shape, and so the only thing that we're doing to it is this minus 2. Well, absolute value gives us the points 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2, and it's going to go on indefinitely in all directions. Now this minus 2, does it directly connect to the x? No, the x is inside a set of absolute values. If the minus 2 was inside here, then it would, but it's not directly connected, so this means it's either up or down. Since it's not connected to the x, that means it does behave, so it will go 2 down. So we're going to take each of these 5 points and just move them 2 down. So this 2 down is there, 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 and there. And so our new graph will just be the absolute value function, the V, just shifted down 2 units. And finally, in this section, we're looking at example number 6. Example number 6 says f of x equals 1 over x minus 2. Now here it may not be quite so obvious, but realize this minus 2 does connect to the x because this is a grouping symbol as well. The fraction bar right here is considered a grouping symbol, just like absolute values, just like the radical, just like parentheses. And so this does directly connect to x. But the first thing we have to realize is this is a reciprocal function because it's 1 over x. So that's the first thing. So we can get some of our points, and those points are -2, -1/2, -1, 1, and -1/2, 2. And likewise 1/2, 2, 1, 1, and 2, 1/2. So this is going to give us the curve that we're so used to for the reciprocal. But this -2 right here, it is directly connected to x, so that means it's either a left or a right. More importantly, it does not behave. This would seem -2 going left or right. Now that seems like I should go 2 left. Instead, we have to go 2 to the right. And so each one of these will be moved 2 to the right. So we get this, this, and this, along with this moved over 2, 2, and 2 like this. And so we get this shape of thing that looks like this. Now it's very important to realize that in a reciprocal function, there are a couple of asymptotes. In other words, they keep getting closer and closer but never get there. One of those asymptotes is the x-axis. And since we didn't move up or down, then that's going to remain that way. So we're never going to cross that line. But secondly, we had the y-axis. But since we moved everything 2 to the right, the asymptote also moves 2 to the right. And so we get this asymptote right here moves 2 to the right. And so those become our boundaries for our new graph. And I do expect and want you to show those asymptotes with the dashed line through there. And make sure that you just get closer and closer, but you never cross that particular line.